Hello. Can you please? Okay, thank you. So, thank you for having me today. I'm going to talk about common WebRTC mistakes and how to avoid them. And my name is Levent-Levi. I'm the author of a website called BlogGeekMe. I'm a consultant and analyst in this space, and I'm also the co-founder and CEO of a company called RTC. What we're going to do today is talk about two things. First of all, a bit about WebRTC, just to understand what it is, what it can do. And then I'm going to give a kind of a shopping list of common mistakes that I see companies make and developers make when they start using WebRTC. So let's start. Now, if you ask me what WebRTC is, I usually refer to these two sentences. So the first thing, WebRTC offers real-time communication natively from a browser. So you have a web browser. Inside the browser, there is an implementation of a real-time communication stack, and you can make use of it. How do you make use of it? WebRTC is a media engine with JavaScript APIs. We can now use JavaScript on top of a web browser to do whatever we want with voice, video, and any type of data. This wasn't there before WebRTC. So this is rather a new thing that we can do in the last, I guess, 6-7 years or so. Now, if we look at how does the stack of WebRTC looks like, there is this illustration that I've taken from a book called High Performance Browser Networking. It is a very good book, so if you want to learn about browser networking, go and read that book, High Performance Browser Networking. The left-hand side is just a stack of how signaling and transport happens in a browser. The right-hand stack is what WebRTC really is. So you've got TCP and UDP, and on top of it, a slew of different protocols that are used to comprise WebRTC. We're not going to go over them. It's just to give you an impression of what's there in WebRTC. Now, one thing to remember, and this is very important. WebRTC is a piece of technology. It is a building block. It is not a solution. You cannot take WebRTC and compare it to something like Skype or Zoom or anything else. Why? Because it's apples to oranges. One is a technology, WebRTC. I can build applications and services with it. And the other is a ready-made service. What I can do is use WebRTC to build a service and then compare that service to something else, to some other service. Okay? So remember, WebRTC is a technology, it's not a service. A lot of the things that you will try to compare WebRTC with depend on what you do in your own implementation on top of WebRTC. Now, how do we make calls with WebRTC? We have two browsers. We've got this redhead guy, he wants to talk to the other guy over there, and you need to reach out to him. So the first thing he does, he sends a message to a server, the web server. This is where my application is implemented that makes use of WebRTC. That server is going to send that message to the other person. We call this the offer. Now, this isn't a WebRTC message, but it does include the WebRTC component called SDP. The other guy over there is going to do something very interesting. He is going to reply with his own message. And that message is going to get to this other side. That is the answer. So you've got an offer and an answer. The magic happens now. These web browsers are going to interact now directly from one to the other, and they can now send real-time media from one to the other. This was never impossible before WebRTC. The only way in which you can send a message directly from one browser to the other is by using WebRTC. Okay? Now, if you want to build something with WebRTC, we need several components. The first thing we need is a browser. Okay? I need a browser that has a WebRTC implementation in it. The second thing that I need, maybe a phone. I want to build an application. I'm going to put it on a phone, in the browser, or on whatever other device that I want to use. Why can I do that? Because WebRTC is open source, I can download the code, compile it, install it, port it, put it wherever I want. And today, we have implementations of WebRTC running on different chipsets and different applications and different devices. On the server side, the first thing we need is the application server. Okay, if you remember from the previous slide, we had one person sending a message that went through a kind of an application server. The other thing that we need is a signaling server. There are two servers and not one, simply because most of the time my web application will sit on a different server or a different process than my signaling server. They serve different purposes. One shows the UI, handles the database or whatever, and the other one deals with the logic of signaling from one user to another within a session. The next thing that I need, NAT traversal, also known as I, stun, and turn. I need turn and stun servers to be able to traverse networks and reach the other user. Because I might sit inside a local network, most likely, and you sit in your local network, somehow I need to be able to reach to you. And we do that by negotiating terms and understanding how that is going to happen. This is what we need in order to make a WebRTC session. We might need another type of server, which is a media server. Okay, let's say that I want to build a conference with 10 participants, or do a broadcast, or record the call somewhere. These types of scenarios require having a media server as part of the process. It's not mandatory, it's not even defined anywhere, but we have it in almost every use case that behaves today in production environments. So how are you going to interact with all of them? We're going to start off by connecting to the application server. The application server needs to have access to both users. We then signal things through the signaling server. And again, these two can sit at the same location on the same process, the same machine, or they can be totally decoupled from one another. Sometimes we will need a media server to send the actual media instead of going direct between the browsers. Why? Because I would like to record the session, or because I have too many users and I can't handle everything on the client side. And sometimes I'm going to need a turn server to relay the media for me, because there will be no other way to reach the other destination. Now, the application server, the way we scale it and manage it and develop it, that's the usual stuff. The same way you build applications today and web applications, that's how you do it with WebRTC as well. Stun and turn, about 15, 20, 10% of the sessions are going to require a relay through turn servers. So you need to deploy them, manage them, maintain them. Okay? How many of the sessions are going to go through there exactly? I don't know. It's dependent on your users and where they are located and how you've configured your servers. Signaling, that's concurrency and scaling. That's what you're going to be dealing with most of the time. How do you manage the different requests that come from the different browsers? How do you scale out and do that in a way that works well? Why? Because this server is mostly stateful. It needs to understand who exists in the call and what they are doing. And last but not least, media servers. The main headache and concern with media servers is going to be throughput. How much data can I pump through these servers? Because we're doing voice and video calls, that's going to be a lot of data, and that means we might need more than a single machine, and we need to scale them out, and we need to see how many sessions can we squeeze into a single machine. Now, something to remember, WebRTC sits at an intersection of both worlds. On one hand, it deals with traditional voice over IP. Half of the specifications there, or even most of them, are simply VoIP standards. The other half of WebRTC is the internet, the web, and it is slightly different than VoIP. The differences there lie in how you develop, how you maintain, how you scale things, and how you even debug stuff within these two services. And because we sit in that intersection, there are a lot of issues and mistakes that developers make with it. Either because they come from this world and they don't really understand the web, or because they come from the web and they don't really understand voice over IP. Okay, so there are a lot of issues that happen just because of that. And now let's start with the shopping list. And the first one, and the biggest issue that happens time and time again, is misconfiguration of not traversal. We have stun and turn servers. We need them in WebRTC. We can't live without them. Okay? And more often than not, I see people misconfigure their not traversal, their I servers within the session. So the first problem, and this is something that you should never do, don't go to GitHub or search the internet for free stun public list addresses or free turn servers. What you'll get is, a shopping list of different IP addresses that does nothing good for you. If you start using them or populate the list with all of these, the time it will take you to negotiate a session will be longer, and you will have too many messages going back and forth, and this adds nothing to what you are doing. So don't do it. The second thing, don't use public stun servers, at least not the free ones. Oftentimes I see people use, just the Google server, Google stun server, and everything works, and they're so happy until one day it doesn't. Why? Just because. Something goes wrong, and now they start complaining. Well, you didn't pay for it. It's a free service, but there is no SLA. There is no guarantee that it's going to be there tomorrow, so why use it? Especially in production. So don't do it. The only reason for using that server is as a fallback mechanism. Okay? If you have your own stun and turn servers, you can add the Google stun servers, for example, as a fallback mechanism if your own servers fall down. But don't rely on it as a first step. Now the biggest problem, don't use public turn servers. There is no such thing. Okay, you might find turn servers and be able to use them. Don't do it. It makes no sense. Now why is that? What turn servers do is relay media. If I want to send media to you, the way I need to do that sometimes is to go through a server that will relay the media for me. This means that all of the data that I'm sending needs to go through that turn server. And that means that someone is going to pay for that bandwidth, and that someone is going to be the person that is hosting that turn server. Because there is money involved, someone needs to pay for it. And if you're not paying for it, then the person is. That person is. With turn, we need this deployment to be global. I want the turn server to be as close as possible to me as a user, and to each and every one of these users. So when we deploy turn, we put them on every conceivable data center that we can put them that is close to the target audiences that we have. Usually in multiple locations. So if you go to a public turn server, you have no clue where is it running. Is it close to your users or not? That's something you need to check. The second thing, it is costing money. And because someone is paying for it, what's going to happen if you use a public server is that at some point in time, they will lock you out. With turn servers, we can put a username and password and then lock out people. If someone doesn't do that or maintain static passwords, then he's screwed. The moment he figures that out, he's going to change that. And if you're going to use public turn servers for your own production-based application, you'll be locked out at some point in time, and you really don't want that. So don't even search for these servers, and don't ask, why isn't Google offering a turn server for free or whatever? No one is. When you look at the actual configuration for I servers within WebRTC, these are the things that I want to see in there. The first two things are turn addresses, and they should be for both UDP and TCP. The first one, that is UDP, also implies that this exact address is going to be used not only for turn, but also for stun, which is okay. You can explicitly add stun, but you're not obliged to do so. The only reason in which you can throw these two addresses if you are using a media server and that media server has a public IP address. Then you don't need the first one. If the server that you are using supports also ICE TCP, then you can throw out the second one. Most often than not, just have these two in your configuration and be done with it. The third thing you must have there is TLS. Why? Because sometimes the firewalls that you need to pass through with your media is going to block you out with UDP and TCP. And TLS might be able to be the only way for you to traverse through that firewall. In many cases, the average is something like 0.5% of the calls requiring TLS. So this is important if you want to serve more users. Last thing I want to mention here, the port that you are going to use. Use port 443. Why? Not because this is the default for the turn servers, but because it is the TLS port. And again, this means that most firewalls will allow you to pass through them better if you use this port and not a different port. Okay, so go check the configuration of your peer connection in WebRTC. Make sure that what you have is UDP, TCP, and TLS. Or at least make sure you have TLS and media servers that support UDP and TCP on a public IP address. And make sure that you use port 443. What will that do to you? Improve the number of connections or the percentage of sessions that will get connected in your application, which is a good thing. What else do you need to take care of with turn and stun? Well, first of all, you need to globally deploy them. It's a headache, but someone needs to do that, and that's you. Make sure to add ephemeral passwords, temporary passwords, to the turn servers. Why? So no one else is going to, hitchhike, take a hitchhike with you and ride on your servers without your permission. You're going to pay for it, so make sure you're the only one using it. Test the configuration to make sure that it actually works. There are issues there, so make sure that it is working and working well. And last thing, monitor the behavior over time. Don't ignore that. We'll get back to monitoring later on. First thing was misconfiguration of turn servers. The second thing that I see a lot happen is selecting the wrong signaling framework. So we've got an application, we have signaling, we have media, we have NAT traversal. Signaling is where I go and send these offer-answer messages to the other side through a signaling server. Now, what do developers do when they did something? Well, they go to GitHub, right? You go, you search GitHub. For WebRTC, you find a project, you download, you install it, and you run it, and you're happy. Everything is fine. The only problem is that there are a lot of projects today that use WebRTC and do WebRTC signaling, but none of them is really well maintained when it comes to signaling. And that's a real problem. And if you look at the sample application that is given by Google, RTC, it's a great application, but it's usually not that suitable for production-based application due to many reasons. So you're kind of stuck with that. Let me show you a few examples of where people make mistakes there. Peer.js, great signaling solution from years ago. If you look at GitHub, it's got like 6.5K stars, a lot of forks going on there. Seems popular, right? You're going to take, download, and use this one. Until you start digging. If you look at the actual source code, you see that most of it got updated last month, which is again great. It means that this is well maintained. Well, guess what? It isn't. This is the Insights tab from GitHub, and it shows the activity over time of what happened with that project. As you can see, nothing happened in 2015, 16, 17, and 18. 4 years, nothing. In these 4 years, a lot of developers tried using Peer.js, even used it and then failed because things stopped working or didn't work well. Now, the main problem that I see here is that here there was a huge spike and then the negative spike of it. I have no clue what that is. It makes no real sense. But something is wrong with this specific project. I wouldn't use it. Okay? I would wait for half a year to see what happens, and then make a decision. It is too early, even if it was updated just last month. Let's take another popular example, RTC. RTC even had a company behind that, again, quite popular. If you go and look at the source, lots of files, you search for the dates, you have two interesting dates. The API got updated 7 months ago, not that good, not that bad. README file 2 months ago, let's go check the README file. Warning, insecure module, do not use in production. That turned out well. Okay, so we had a project, RTC, well maintained in the beginning, today relatively dead. Okay, when you are using a signaling server, make sure you understand what you're doing, and even more, make sure you know how to maintain the code on your own. You're going to have issues if you don't. This last one that I want to show is Muazkan WebRTC experiment. A lot of people go to that website, 7.6K stars, 3K forks for the code. Lots of activity. Great project. Now the only thing with this project is that it is not a signaling server. The only thing you get here is experiments. It's pieces of code that shows a proof of concept, a demo, or reference that you can copy-paste, and then heavily modify to fit what it is that you need to do. So take that into consideration. Use the code here, but assume and understand that you need to make it your own in order to make it work. You can't just take it and forget. And that's the case today with most signaling servers on GitHub for WebRTC. Third problem, testing locally. Here's what happens a lot of times. If you go to Stack Overflow or discuss WebRTC, there are a lot of interesting questions over there that relate to this thing exactly. My home network starts with 10.0.0.1. That's my laptop at home, or my desktop, I think. If I take my two machines at home, try to connect them in a WebRTC call, it is going to work perfectly well. This one 10.0.0.1, that one 10.0.0.2. Why is it working? Because I'm going to send the data to the signaling server. In that, I'm going to have these IP addresses. The browsers are going to check if these addresses can connect them, and miraculously they can because they sit on the local network. Now, the moment I will go to production and try to use it in a live environment, this is what is going to happen. I'm going to have a firewall somewhere in between, on both ends. And I might even have the same IP address, local IP address for both machines, because nobody cares anymore. Why? Each one has his own public IP address. And somehow these two need to negotiate that information. And they do that using a STAN server. They might need to relay the media. And they do that using a turn server. If you're doing testing only locally, the end result is going to be that you're not testing anything. You're testing the wrong things when it comes to connectivity. So bear that in mind. Make sure you configure the firewalls properly, make sure that you configure STAN and turn properly, and make sure that you test it. What are the things that you need to consider here? First of all, different regions around the globe. If it works in a certain location, it might not work in another. That applies a lot for network conditions and firewall configurations. If it works from a machine here, it might not work on a cellular network, or in your office, or in your home. Why? Because the network is configured differently, and there are different firewalls that you need to traverse. So test these things. And check it with different operating system and browser versions. There are bugs in them and different behaviors. These things apply. You need to make sure that these things work well. Fourth thing, ignoring or forgetting security. The nice thing about security is, for the most part, most developers don't think about security, don't care about security, and that's like the last thing that they do. Why? Because we want to build our applications and we care about the usability. Now with WebRTC, it's easy to forget. Why? Because WebRTC is secure. If you look at the media that passes through WebRTC, it uses a protocol that is called SRTP, Secure RTP. It means that whatever you send in terms of the media with WebRTC is always encrypted, so there is no problem, right? Keys are exchanged with DTLS. DTLS again secure and private and encrypted, so nobody cares. And then the signaling part, WebRTC forces you to use HTTPS or secure WebSocket. So again, we don't need to do anything, it just works. Well, you have a role to play on your own with security. You can't rely on WebRTC doing everything for you. Again, WebRTC is a technology, it's not a solution, it's a building block. Your application takes care of the logic of this end of the signaling. These things you need to secure on your own. Turn server access, using passwords there, that's an issue that you need to deal with. Dealing with media server resources and how to secure them, that's your role to deal with. Okay? Keeping up with the different WebRTC releases to make sure that you have all the security patches in there and all the fixes, that's up to you. A lot of things that you need to take care of. So WebRTC is secure, your application, you need to take care of that. Bear that in mind. We talked about the need to monitor at the beginning with misconfiguration and the fact that you put your turn servers out there and build them and manage them. One thing that I see over and over again, people build their applications, deploy them to production, but they never collect stats and traces. And then this happens. What is that exactly? This is a customer complaining. He's saying something like, well, I can't erode you. The video is crappy. There's packet loss. The frames look weird, whatever. The problem here is that it's not always under your control. You've built the application, you've deployed it, you've put it on the best infrastructure money can buy. But if I connect to the network from my phone over there, and I do that over a local Wi-Fi or from a hotel Wi-Fi, which is never good, okay? Things are going to not work. Not because someone deployed the service bad, but because the network that I connect to the other side or to the infrastructure is a poor network. It might be on a lead line, on Wi-Fi, on cellular. As a service provider, there is no way for me to know what my users are going to use. And that means they are part of the problem. Okay? Things like the number of devices on the local network. You take a contact center. There are 200 agents, all of them on their phones. All of them using WebRTC over the network. There needs to be a nice internet connection going out of that system towards the network. You do a call from home, and then your daughter decides to do a TikTok, movie. She's changing everything in terms of the dynamics of what happens in your network. And that's going to affect the WebRTC call that you are doing at the same time. Browsers that get upgraded. You can't tell Google, don't upgrade the browsers that are using my service. If tomorrow there is a new upgrade to the next Chrome release, that is going to happen if you like it or not. Same applies today to Firefox, to Safari, and to all the other modern browsers. Why? Because they upgrade automatically. And whatever happens, your customers are going to assume that you are to blame. They're having a problem, the problem is you, not them. Why? Because you provide the service. Oftentimes, it's not you, it's actually them. How are you going to tell them that? How are you going to know that the issue is them and not you? The only way to do that is to collect data, analyze it, and understand these issues. So make sure that you do that. First of all, you need to log the information. With voice over IP, we usually logged stuff from the server, and that was enough. But with WebRTC, something weird happened. Most of the services and the solutions today started logging on the devices, or from the devices, and not from the network. It happened because of two things. The first one is sometimes I don't even pass the media through a server, so nobody knows about the issues that happen besides me and the other person. The servers don't know. And the second thing, with WebRTC, everything is encrypted. So a lot of the things that I can see happen only on the device. So understanding what happens in the device is very important. So if you're trying to pick a logging strategy, think about how you collect data from the devices. Collect also from the servers, but try to collect also from the devices. What are you going to collect? Everything. Whatever you can collect, go and do that. Collect the statistics that WebRTC gives you. That's get stats. Collect the operating system, machine, device, versions, whatever is there, collect it. You will need it. A lot of these issues happen in a specific operating system, in a different browser, on a specific release. And sometimes you will need that information to figure out what the issue is. Once you collect, have the means to analyze it visually. Be able to see a single session or be able to see an aggregate of data across your infrastructure. Why? To find different trends and issues and where they apply and how. If you want to get started with that, look at RTC stats. There's a good GitHub project today on Live on Air. Okay, this helps you collect data directly from the browser with WebRTC. The sixth thing, thinking short term. This also happens a lot, and it happens from the people that end up using WebRTC. A lot of the people that build stuff with WebRTC are entrepreneurs. Okay, they are dreamers. I have a thing that I want to build. I want to build a solution for veterinarians so that dogs will be able to go and get a visit from a veterinarian remotely without coming to my office. The person that decided to do that is not a developer. He's just an entrepreneur. Okay? And he doesn't know all of the issues that relate to building things with WebRTC. And what exactly do I mean? If you look at browsers today, Chrome, every 6 to 8 weeks there is a new browser version. I think we started with WebRTC somewhere in version 23, 30 something like that. Today we're in 70, 76, 77, we're talking about 79. Okay, these versions run really fast. Firefox just announced last month that they are going to try again to go for a version every 4 weeks. That's great. These versions break things around, especially with WebRTC. Every new release has its own surprise for developers. It's a headache that we deal with as developers. And the thing is, all of these releases don't really include the small security patches that go in there, or the experiments that Google is running on Chrome that are going to put additional surprises on the things that we're doing over and over and over and over again. Okay? We have WebRTC 1.0. For the last 2 years we've had WebRTC 1.0, but it hasn't been released yet. We're using a specification that is still not specified, and that browsers don't really implement in the way that it is specified yet. Google just came to the point this month of saying we have a huge milestone, we reached WebRTC 1.0 in our code. Not what is released to the market, but in our code base. Without bug fixes and interoperability and everything else that goes into that. What does that mean? That while people are using WebRTC, you should expect changes. And again, this doesn't include all of the other changes and optimizations and new codecs that come into WebRTC and join this huge party of the things that we're doing with WebRTC. And once that will be complete, we've got something called WebRTC NV, next version. There are discussions of what should be added to WebRTC moving forward. What things can we add for developers so they have more flexibility, better control, and additional use cases that they can have. What does that mean? That we need to look at this as a whole process. Okay? I have a dream. I want to build a solution for veterinarians. I'm here. I'm thinking, how can I implement this thing and go to market? And if I simply do that, I go to a company that is an outsourcing vendor, give them the work, they build it for me, they ship it and supply it, and everything is fine. 2 months later, it's going to break. Or 4 months, or 6 months. At some point, these services will break. That's a guarantee. It means that if we're going to build something with WebRTC, you need to think about the whole process. From design, okay, how do I build it? How do I configure the not traversal servers? How do I deal with collecting the data so that when customers and users complain, I can validate where the issues are? Then you need to implement, and then you need to maintain. And that maintain part includes developers that will do bug fixes on the existing code, even if there is nothing more that you want to build. By the way, this is one of the reasons that developers go to companies like Agora. Because Agora does all of that part for you, and you just deal with the API on top of it. Okay? So there are 2 routes here. Either you go and develop these things in-house, and then it's all your headache, which is a lot of fun. Really, these are the things that I like doing. Or you can use a third party that will do these things for you, but you need to make sure that they also maintain it for the long run. Okay? Now, the last one is failing to understand WebRTC. Now, we've said that WebRTC has 2 parts to it. There's the voice over IP world, and then there's the web world. Most people come either from voice over IP, and that's what they know. So they know very little about the web and how that works, or they come from the web, and they don't know how voice over IP works. You need to understand both of these things in order to understand WebRTC. And if you don't, you're going to fall into these mistakes that I've shown, and other mistakes that are out there. Okay? If you want to learn more, you can go to blog me into WebRTCcourse.com. There's also a discount for the course, and if you want, there's a flyer over there with information about the course and the discount. Thank you.